oh, I know what else I forgot. I need to go on YouTube and mute myself, otherwise I'll hear myself. Nope, that's wrong. That's okay. Okay, is it working now? Goodness me. How are you all this morning, afternoon? I think I've got everything working now, so I can talk to you properly. So this session is going to be, it's designed to be around VT graphs. And the reason that it is designed to be around VT graphs is not because they're especially difficult. And, oh, I haven't made a worksheet for this one. I'll explain why. Oh, and also, hello to people on YouTube. This is a live stream of the class that I'm running for my TT students. So if you see me talking to what appears to be myself, I'm actually responding to the questions in the chat of the Zoom class. If you want to join the Zoom class, then you can make a free trial of Tailored Tutors and go in the maths course and click on live classes, and then you can join in and ask questions. So yeah, if I look like I'm talking to myself, YouTube people, I am actually really talking to real people. So Ola, the reason why there isn't a worksheet for this one is I'm going to combine two things for this session. I'm going to talk about VT graphs, and we're going to do some VT graphs practice, and we're going to summarize it down into what you absolutely need to know and how to approach the problems. But I also want to use this topic as an opportunity to show you how you could do an action hour, a revision session on a topic you're finding difficult, any topic. So it's going to be a combination of those two. It's going to be a sort of general lesson. It's going to be a sort of general lesson. Just muted myself on there. It's going to be a general lesson about VT graphs, but it's also going to be a specific lesson about revising. So hope that makes sense. I'm going to share my screen with you and show you where we would start. So let's say we've done a past paper and we've realized that VT graphs is a bit of a problem, or any topic is a bit of a problem. Maybe you're using the TT method and you've come across a question and you're going to do your action hour, or maybe just you need to catch it up from school or something like that. So we're going to start on the revision pack page for that topic. Now, I want to put a proviso in there that when you're revising, excuse me, one of the common mistakes that students make when they're revising maths is that they think they need to work on the thing they're finding hardest. Okay, so whatever you're finding hardest, I know this does make sense, whatever you're finding hardest, go and work on that topic. Now, what this ends up creating is a situation in which you're putting a huge amount of effort into something that's very difficult, hardly ever comes up, and is worth very few marks. So just because you find it difficult doesn't mean it's important. And that's a really important distinction when you're revising. And that's what the TT revision method does for you. So you fill in your MID sheet, and maybe there was a question on range and domain if you're a second year, or maybe first year there's an optimization question that you found really, really difficult. But your MID sheet says that you lost more marks on something else. Then it directs you to that something else, because that's where you lost the most marks. And that's really how you should guide your revision. So if you're preparing, Ola, all the MID sheets are in the exam guide. And if you are in the exam guide on any, whichever exam you're doing, EdXL, AQA, OCR, whichever one, go to that paper and it will be right there for you on that page. Let me know if you can't find them and I'll send you a link. So it's a really good, TT method is a really good structure for your revision. Now you can also use TT method when you're doing topic revision, okay? But my proviso, don't forget that some topics are more important than others. So don't give all topics equal value. So a good place to start, we've decided we're going to do VT Suvat for whatever reason. We come in and we have a look at the revision pack page. Now, first thing you've got is a short-ish video, about half an hour, covering the whole topic. So first years, you would only need first 10-15 minutes of this because you're not doing projectiles. I make it really clear when it switches from first year to second year during the video. Second years, you should watch the whole thing. You can print out the revision notes on the right-hand side, and then you can fill them in as you're going. And that means that that's going to give you a reassurance that you know everything, that you've got everything contained onto 1 or 2 sides of A4, and that there's nothing that you should find in a textbook that you might need. It contains all of that sort of precursory work all down to half an hour, which is really good. But you don't have to watch that and make those notes. If you think you already know this topic, go straight in to past paper questions, because that's where you're really going to learn. Everyone knows that about maths. You don't really learn until you get on with it. Down here, there are also the individual lessons and the resources that you might need when you're using those lessons, or all the other cheat sheets and stuff that you might want for the whole course. So if you are sort of going to do a real comprehensive, spend a few days on this topic, that bit is going to contain everything you need. But I think at this stage, what we need to do is focus on the past paper questions, okay? So they're split up into easy ones and medium ones and hard ones, and also AS and A level. And then what you can do is just pick a few and line them up with tabs. So that's what I've done at the top here. So all I've done is look at the VT graph ones and then open all of these tabs. Now, if you've done these questions before, it will show up what your traffic light was. So you might start by going, oh, there's a red one that I obviously couldn't get before, so I'll start that. Yes, got it, but then better organized here. So I recommend you go, if you're looking for documents, you go to the individual revision pack page, and then all of the course ones are on every single one, just for wherever you are. So that gives you the ones like on that topic. Okay, so this section here, this isn't just where we would go and grab a load of questions. Okay, the other thing that you can do here is have a quick look at the notes on the right hand side. So I put notes in here if it's something that might draw your attention to a particular question or make you think, oh, I don't need to do that particular question. But one thing that's really interesting, if you look down here, is that about half the questions that have been set on VT graph in the last few years since the new spec started have a word question in, asking you to explain why or suggest a refinement. So 50-50, you can predict that the question you're going to get in your exam, regardless of whether it's a real exam or your teacher's setting it, because if your teacher's setting it, they're probably going to be using some past paper questions or exam board questions, and half of these contain this word question. So what you could do is just grab these 4, have a quick look at the word question, jot it down on your notes, and then you start to collect the sorts of word questions that come in with certain types of questions. And you start to get a feel for where they're going to be. Second years, have a look at the projectiles down the bottom there. You can work really hard on projectiles, but drop 1 or 2 marks because you're not answering the highly predictable word question that they're going to ask at the end of the projectiles question. So that's what you can use this for as well. Okay, we've got our questions all lined up here. And the next thing that I would suggest that you do is just have a flick through. So we're not going to ruin the question by looking at it. Just have a flick and see what they look like, whether they've got the same style, the same format. So we've got a graph there that goes below. We've got a graph that goes below. Oh, this one, you've got to draw your own graph. This one, you've got to draw your own graph. This one, you've got to draw your own graph. So lots of own graph drawing. So that might be something worth practicing, that you think, oh, actually, I haven't done one of them for a while, where you have to draw it yourself. This one, graph, but it doesn't go below. Graph that goes below. So you can see that graphs that go below the time axis, so this is negative velocity, moving backwards. Above the t-axis, moving forwards, below the t-axis, moving backwards. So it gives you this real feel for the sorts of things that come up and can help you to decide what order to do these questions in. The other thing that you can use to decide to do all these questions in is have a look at the title, and it contains an A, an E, or an M. That's apprentice, expert, master, easy, medium, hard. So this is a middly hard one. So what you can do then is take the questions that you think you're going to have a go at, and this is a master question. I'm going to move that to its own tab, apparently. That's how hard it is. So you can move them around depending on whether they're easy, medium, or hard. And then what that's going to give you is a nice setup for your action hour. Now, next thing of an action hour, and then we'll come to some actual maths, because this is all about how to revise, is to use the timer in the top right. So either on your phone or the timer that's there or on an application, set a time for your study. I was talking to a student this week about it, the idea of feeling quite stressed about not knowing how much to do, not knowing how to balance time on different things. And the one thing that I really, really recommend, oh, Tris, hi, I replied to you yesterday. I'll read that in one sec. So one thing that I was talking to a student about yesterday is the idea of, instead of setting a job list or a task list for the day, I'm going to do this, I'm going to do this. Instead of doing that, you start the day with 4 action hours that are blank. And in the day, that's your target. You can do more if you want afterwards, but that's your target. So you start the day, and I use this every single day. It really, really helps me with work. Start the day with your 4 blank action hours. Now we sit down and we're like, right, I'm going to do my first action hour, and it's going to be on VT graphs. Set a timer for 45 minutes. Try not to study for more than 45 minutes at a time without a break. Then at the end of that 45 minutes, you have done your action hour. The action hour, the target is to focus for 45 minutes on VT graphs. It's not to do 4 questions or to do 6 questions or to write out revision notes or anything like that. You can't fail. The only way to fail is to go off task during the 45 minutes. Now, this really, really helps because, sorry about the Deliveroo bikes. This really helps because it takes away all that pressure of, I need to achieve this, I need to get this done. And what my brain does is at the end, all the time calculating, like, well, hang on a minute, if that took me 20 minutes, I've still got all of this to do. Calculate, go off task, start stressing about how long the whole thing is going to take me, start to feel like a failure, stop working. So that's a very common way for brains to work. So we're going to set a timer. We're going to do 45 minutes, or in our case, we're going to do half an hour. And then at the end of that, that is our first action hour of the day done. When you've done 4, you've done your study for the day. If you want to do more, you can. But if you don't want to do more and you're tired and you're not in the mood, you do not chastise yourself or criticize yourself or anything like that, because you've done your study for the day. So it's a very different way of thinking about how to do a study planner. There is a study planner based around this idea in the TT course in the common room. If you can't find it, let me know. So Tris, you're wondering if you can use OCR resources even though you're doing OCR MEI. Right, this is going to affect very few people, what I'm about to say, probably only Tris, is that OCR MEI is a harder specification for 2 reasons. One is the A-level paper 3, which has got the comprehension section, which let's forget that, because that is just the weirdest funny thing. And preparing for that is more like preparing for a step exam or a, like a proper maths exam. So that's very different. And I will talk to you separately, Tris, about that in the course. The other reason why MEI is harder is that some of the questions, some, not all, some of the questions are less structured. I have started adding in MEI papers for people who want to do sort of really pushing for an A star. So Tris, first of all, the answer to your question is yes, all the specs are the same. OCR, EdXL, OCR, MEI, AQA, all the specs are the same. So you can use any set of questions. If you have specific MEI questions that you want help with, just take a photo and put it in the comments and I'll help you with it. And also, if you have a look in the TT method group, there's an MEI paper there. And I've started to put those MEI papers in just to help students who want a bit of extra help. Yes, Ola, definitely you can implement this to schoolwork. I use it, the idea of the action hours and the focus and not having a to-do list, I use that for my real work all the time. Okay, let's do maths. I promised a 10-minute introduction and it was actually 15 minutes, but it wasn't really about VT. So here I will now teach you everything you need to know about VT graphs. 1, in fact, let's write these down. Let's grab a piece of paper and jot them down. There's only 3 things. And obviously, if you watch that revision thing at the top, then you'll already have these. So first thing to remember is that on your VT graph, there is above and below the axis, whereas we normally draw them like this. With a VT graph, always try to draw it with the t-axis right in the middle to remind yourself that the particle can go forwards and backwards. So up here is forwards and down here is backwards. And that's if it's horizontal movement. If it's vertical movement, if it's a ball being thrown up in the air, then at the top is up and at the bottom is down. Okay, now slight tiny proviso is that with, hopefully from doing your SUVAT work, that when you have a ball that's thrown up in the air and it goes up in the air and then it goes down like this, it is actually up to you which way is positive. You can have up is positive or you can have down is positive. It's totally up to you so long as you're consistent. So it would be possible to have a VT graph for vertical motion where I've decided for some reason that down is positive, in which case that would be down and that would be up. So I'm just being like super duper like lawyer levels of like provisos here, just to be very careful with. But that's step number one, is to understand those two sections. And as we saw, that does come up quite a lot, that you need to understand those two. Second thing is that gradient is acceleration. And the third thing is the area under is displacement. So when we've got our two sections, say it looks like this. This is me moving forwards, all the way across there, forwards, forwards, forwards. I've got no velocity. I'm speeding up, speeding up, speeding up, speeding up, and then slowing down, slowing down, slowing down, slowing down. And then I stop. But I've moved forward that whole time. So that area there is how far I've moved forwards. And then I turn around and I start going in the other direction, speeding up. So I'm now going this way, speeding up, speeding up, speeding up, speeding up. So all of that area is displacement backwards. So if you want to know where I end up relative to where I started, you'd have to do this, this minus this, okay? And that is literally it. That's all they're testing. There is no other information at all that they could possibly be testing. So if you focus on that and you think, right, this isn't complicated, if I use these two facts, I will be getting marks 100%. So just use those two facts, and then what you'll find, hopefully, is that the answers drop out a bit more easily than you might be expecting if you overthink it. So the topic here reduces to, they are testing two things. This is what you say to yourself. This is not a hard question. They are testing two things. So why don't I just find the gradient of that line and put it equal to acceleration and see what happens? Why don't I just find those areas and see what happens? Last but not least, how do you find the area of a parallelogram? Because this happens a lot. You do, but what you'll find is that it's the other way up, like this. So you do this plus this times half of this. This plus this times half of this. Now, this brings me to a little exercise I've got for you. So grab a piece of paper and we're going to have a look at a question which comes up now and again, not all the time, but of the 1, 2, 3, 4, 5, 6, 7, 8 questions here, it has come up. It's come up for, I believe, AQA, but it hasn't come up yet for EdXL and OCR. Now, the thing I just told you, here's your VT graph. You've got to find the area under the graph. There's the graph. So we've got a trapezium. And how do we find the area of a trapezium? We do this plus this times half of this. Now, in the scenario of a VT graph, that's time. This is a velocity, I'll call it u. This is another velocity, I'll call it v. So this area in here, this displacement in here, is u add v times half of t. Now, do you recognize that equation? Exactly. It's one of your SUVAT ones. Right, what's the other piece of information that they can test? I'm not poorly, but I don't know what is wrong with my throat the last few days. I just sound like I smoke 40 a day or something. Acceleration. I think when I give you this task to do, I'll mute myself and just cough until I'm not sounding like this anymore. So that's the first thing they test, is displacement is the area underneath. The next thing that they test, there's only two, is that acceleration is the gradient. So let's have a look at that. Here's the line. The gradient is the change in y over the change in x. So the change in y is this bit here, and the change in x is this bit here. Yeah, A equals v minus u, change in y, divided by change in x. Rearranges to, there we go, your second Suvat equation. So here's the task I'm going to set you. It's just going to be a quick one. I'm going to give you about 3 minutes to just play around with this, because you can do it afterwards, and all of the full solutions are in the course if you want to check it. But what I want to task you with for the next 3 minutes is to come up with the other Suvat equations. So this isn't just an exercise in fun. This is a relatively common exam question. As I say, it's already come up once in the last 3 years. I'm sure it will come up again in the next few years. And it's a nice one for teachers to choose to set for students, because it's sort of nice to test whether or not you understand that when you're doing Suvat, really you're just doing VT graphs. There's no difference. Suvat is what we do when we have constant acceleration. So we have these magical equations that we can fill in and use when we've got constant acceleration. But constant acceleration is just a straight line section of your VT graph, because the acceleration is the gradient. So anytime that you're using a VT graph and you've got constant acceleration, and you're using the fact that the area underneath is the displacement, or the acceleration is the gradient, you're actually using these two Suvat equations. And when you use all of your Suvat equations, you're actually just using these two facts, because these two facts give you all 5 of your Suvat equations. So the question that is set in the exam is to use the VT graph to show that, and then they choose one of the 3 Suvat equations that isn't one of these two. And what you do is you do simultaneous equations. So have a go now. Try to use this one. This is just simultaneous equations, which is almost all of mechanics. Comes down to skill. I know it's boring, but nearly all of mechanics comes down to skill in simultaneous equations. So these are our main 2. The other ones, you get by doing simultaneous equations on these 2. So for this one, it's got no t in it. So you would be making both of these say t equals and sticking them equal to each other, or make one of them say t equals and stick it in the other one. For this one, there's no v in it. So you would make one of these say v equals, which it already does, and stick it in the other one. This one has got no u in it. So you would make one of these say u equals and stick it in the other one. Okay, I'm going to give you 2 minutes just to have a little tiny play with that. And that will be one of the questions that was set recently by examiners. Meanwhile, I'm going to mute myself and stop myself coughing. Okay, hopefully I'll stop coughing now. That was 1 minute. I'll give you one more. Give me a shout if anything's not working. Okay. How did you get on? Did anybody manage to get one? Just going to find the questions to prove it to you that this was a question that was set. Where did I put it? Oh, maybe I didn't. There it is. Excellent. So this is the question that was set. It looks terribly scary, right? But it's actually not. So they have, there's your VT graph, and you're gonna, they've told you the one that is the area under is the displacement. And then they're saying by considering the gradient, write down a formula for the other one. So that's the one that gets you V equals U plus AT. And then I didn't screenshot it, but part B was then to prove that V squared is U squared plus 2AS. So it's not one of those questions that teachers set. Obviously I didn't cough enough. It's not one of those questions that teachers set like just for fun. It does come up, and when it comes up, it looks quite scary, and it's actually quite easy. So definitely worth practicing. Okay, shall we start with one that looks like this, where it goes above and below, and it has all different types of gradients there. Okay. Yeah, so let's have a go at a question. So this is what you'd be doing with your revision. Come to the question, and first of all, just have a go at it, play around with it, and then you can use the videos to get help, and you can ask questions as well to get help. So first of all, we just have a look. Find the maximum magnitude of the acceleration. So this is an object moving in a straight line, but it starts by going backwards. So imagine it going backwards, and this is not where it stops. That's not it stopping. This is it stopping. No velocity is stopping. So this whole time it's moving to the left, then it stops, then it moves to the right, then it stops, then it moves to the left. Okay. We've got two facts that they're testing. They always test two facts. And this one, they're testing whether or not you know that acceleration is the gradient. So this says, what is the biggest gradient? That's what that says. So, I mean, that bit, is that the steepest? I think that's it. 1, 2, oh, this bit. Yeah, exactly, Scala. But you don't have to find the acceleration of all the bits, because it's obvious that some bits are slower, yeah? So a shallower gradient is a slower movement, because the acceleration, a slower acceleration, yeah? So you could, no, very good question, Reba. Does it matter that it's deceleration? No, because of this. Well, strictly speaking, because of this. So, you know, with displacement, we've got distance and we've got displacement. And displacement is a vector. Distance is a scalar. So displacement has a magnitude and an acceleration and a direction. Direction and a magnitude. The magnitude is what we call distance, and the direction we use with a plus or a minus, or we say up and down. Velocity is the same. We have velocity and we have speed. Velocity is a vector. It's got magnitude, and the magnitude the word we use for that. When we say the magnitude of the velocity, we don't say that. We don't say the magnitude of the displacement, we say distance. We don't say the magnitude of the velocity, we say speed. And then we've got the direction, and again, for directions, we use plus and minus. Now, what about acceleration? Acceleration is a scalar, and the word we use for the vector, brilliant, is acceleration. Great. So acceleration is a vector, it's got magnitude, and the word we use for the magnitude of the acceleration is acceleration. So we don't know, not like velocity and speed are different things. Acceleration and acceleration are different things. So that's why they've had to include this. The magnitude of the acceleration is just how much the speed is changing per second. So it doesn't matter whether it's going right or going left. It doesn't matter whether it is accelerating or decelerating. It's the rate of change. It's how if you were in that car, how would it feel? Because we don't feel speed in a car, we only feel acceleration, and an aeroplane too. Okay, so hopefully you've got an answer to that one. The object is at its starting position at times 0, t1 and t2. Find t1 and t2. So we know it goes left, then stops, then goes right. Now, at some point, when it's gone left and then stops and then goes right, it might get back to where it started. When it gets back to where it started, its displacement is 0. So the amount it went to the left equals the amount it went to the right. And then that will give you a time when it gets back to its starting position. Now it goes right. Off it goes, off to the right, blah, 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 miles and miles away, stops, turns round and starts going left again. And at some point, those two areas will be the same. So the distance it went right equals the distance it went left. And that's when it's back at its starting position. And then it continues on its journey to the left. Okay, I'm not going to give you very long on this, a minute. Have a little play around, see if you can get an answer for A and B, literally 1 minute, and then I'll tell you the answers. Oh, Afia, it's not 8. The answers are not 8 and 14. That was just me showing what we're looking for. So what we're looking for is when the area under the first bit, so that's how far it went to the left, equals the area at the top. So what you're trying to find is the time, which might be 8, but probably not, the time when that area to the underneath, which is it going left, equals the area at the top, which is it going right, because then overall, if those two areas match, then its displacement is 0. It's come back to where it started. So I was just drawing a random line to say there's a point somewhere here when it gets back to where it started, which is what they're calling T1. Does that make sense? Yes, exactly, Scarlett. So if that area under the first bit, that triangle, if that area is 4, that means it goes left 4. So then we'd be saying, okay, how long does it take to go right 4? So the bit at the top, the area at the top is it moving right, and the area below is it moving left. So first of all, you'd need to work out how far left it actually goes. Then you'd have to look at that top bit and say, how many seconds does it take to go that far? Because that is the moment when it returns to its original starting point. If it's got, I'll tell you the answers. And if it's got in a muddle, or you're not sure, anybody at all isn't sure, then I will go through it in more detail. Okay. So answer to the first one is 4 meters per second squared. And the answer to the second one is that randomly, I did choose the right point. Randomly, T1 is 8 seconds. Those red areas are the same, and that was completely random. And then T2 is 14.25. So I wasn't far off with my guesses of the areas. Would anybody like me to go through any of that in more detail from the class? Do you want me to show you how I got 8 or how I got 14.25? Yep, no problem. A few people saying go through part B. Okay. Just going to try and make this a bit smaller. There we go. Right. So did you manage to work out the area that we go when we're going left? Let's do half base times height. So that's 5 seconds there. This is me working out this red area. And this height, perpendicular height of the triangle is 2. Half base times height, half of 10, 5. So it goes 5 meters left. Let me know if I go wrong, because those of you that know me know that as soon as it's actual numbers, my brain becomes useless. Okay, so what we're trying to do is we're trying to find the time somewhere here, the time at which I have now traveled 5 meters back again. So I've gone 5 meters to the right. So I'm now back where I started. That's what we're trying to find. So we're trying to find that time. So this is a trapezium. We are going to do the parallel bits added up times half the distance between them. So looking back at the graph, this point here, which is where it momentarily stopped going left and then it's going to turn around and go right, that was 5 seconds. So this is T1 minus 5 is that distance across there. Looking at the graph, we can see that across there, well, that bit there is at 6 seconds. This bit here is at a time I don't know. So this bit across here is T1 minus 6. And the height is 2. So the area of that trapezium is T1 minus 5 plus T1 minus 6, the 2 parallel bits added up, times half the distance between them. Now, that area is how far it's gone right. I am not trying to find out how far it's gone right. I know how far it's gone right. It's gone right 5 because I want it to get back to its original starting point. So that would be what I solve. Does that work? This is always the scary bit when your teaching is like, is this actually going to give us the right answer? Let's see. So we've got T1, add T1. And then, wait, this doesn't give us 5, does it? Minus 5, add oh no, it does. And it's not trying to give us 5, it's trying to give us the time. Minus 5 minus 6 is minus 11. 5 add 11 is 16. Good, phew. What do you think? Make sense or not make sense? I think the hardest bit is this bit. Like just classic mistakes. Oh, Ariba, why didn't I write a half outside? Because it's half the distance between them and the distance between them is 2. So that number there is half of 2. I should really, for showing you the method, I should really have written it like this, half of 2. Yeah, Afia's completely right. The hardest part is to visualize it. And my advice to you is don't try to visualize it. Just draw it out, draw it on the graph, draw it to the next of the graph. We can't do these things in our heads. We have to draw them. And I think the T1 minus 6 and the T1 minus 5, that's the most classic bit to get wrong. And that you get from practice, basically. Once you've done the mistake a few times, it forces you to actually think about those distances. Why is it 4 and not minus 4? Oh, because for part A, because it says the magnitude of the acceleration. So this is like if I say to you, what's the maximum speed? You can't say minus 4 because speed is always positive. Distance is always positive. Velocity, displacement, they've got pluses and minuses to show the direction. That's the direction part of the vector. And for acceleration, we don't have a word like speed or distance. So you have to say magnitude of the acceleration. You can't say, like, if we wanted speed, I wouldn't say magnitude of the velocity. I'd say speed, and then that would always be positive, the same as distance. So the magnitude of the acceleration is always positive. It's the length of the vector. It's the number, not the plus and minus. Okay, shall we try another one that's got this above and below thing and see the similarities and differences of the questions? So this is the sort of thing that you do when you're revising. You've got them all set up there, but you can look through and say, actually, I'll have a go at one that looks similar. So where's that other one? Other one that went below. Did I not screenshot them all? That doesn't go below. Well, I suppose we could try this one. Let's try this one. Okay, so this is 6 marks. Every 10 marks is a grade. So this is half a grade, if we can get this completely sorted. So 6 marks is about 6 minutes. I won't give you 6 minutes because we're not going to do it properly, but I will give you 2 minutes of me being silent for you to just have a go and see how you get on, so you've got some context for when I do it. Okay, so just 2 minutes. Okay. Constant acceleration. Now, in this case, notice it doesn't say the magnitude of the acceleration, it says the acceleration. So in this sense, when they use the word acceleration, they mean it as a vector. So this is the magnitude of the vector, and this is the direction of the vector. So pluses and minuses are actually directions when you've only got one dimension. So this is the difference between the magnitude of the acceleration that it mentioned before in the last question and the acceleration. So what are they testing? They are testing gradient equals acceleration. So they're telling you the gradient is 3/4 positive, so a positive gradient of 3/4. So that gives us this. Okay, that's 4 seconds. The next 5 seconds, so that takes us up to 9. It's got a gradient of -1.2, and that should get you to 9 minus 3, like that. Don't draw it like that though, or you'll lose a mark in the exam, because I haven't actually ended up at 9 minus 3. I'm a bit above it. Then it has no acceleration, no gradient. So they're only testing the same thing over and over. Do you understand that gradient is acceleration? So now it's got another 33 meters at constant speed. So but when does it stop? It doesn't tell me how long. I need to find out how far. This is 33 meters. So I need to think about, in that case, how many minutes is it? How many seconds is it? Sorry. Because they're telling me this. Note this, 33 meters. So they're testing number 1, do you understand that gradient is acceleration? And then they're testing what a surprise. Number 2, do you understand that 33 meters tells you that the area underneath is 33? They're only ever testing 2 things because there's only 2 things to learn. So they're only ever testing those things. So if that's 33 meters, then this here, time, times this, which I happen to know is 3, is 33. So that must mean that the time is 11, which means that we end up at 20. So that's when we'd stop. And the thing is, I think coming back always to that principle that they're only testing 2 things is going to really help you to do it. Christine, your question, it's not a silly question. Does it always start from the origin? The origins in maths are whatever we decide they are. So let's say that I've got a particle and it starts moving and it's here. Then I just say that's the origin. That's my origin. And so in terms of modeling it, I just imagine wherever it starts, that's my start point. And it starts at rest. So the origin is time is 0, velocity is 0. Does it always start at the origin? No, not if the velocity at the beginning isn't 0. But if it starts at rest, which it says here, then that tells me that begin, that's time is 0, rest, that's v is 0. So not a silly question at all. Great. Okay, part B, find the distance of the car from P after 20 seconds. Exactly the same question as before. Exactly the same question. Why? Because they can only test 2 things. And no matter how creative your examiner is, there aren't that many questions you can ask that only test 2 things. So the distance of the car from P after 20 seconds. So this is forward. This is back. Okay, so it goes forward a certain amount, half base times height gets us that. It goes back a certain amount, half base area. Well, you could do a triangle plus a rectangle, or you could do the area of a trapezium. It goes back that far. And it ends up at 27 meters away from where it started, but I haven't seen anybody in the chat putting 27. So let's have a look, see what's going wrong here. So this is the forward movement, half base times height, half. Oh, my line isn't very straight, is it? Does anyone know when it goes through there? Oh, I see. Yeah. So that's what I was saying at the very beginning about this first point, the things they are testing, that is really important to remember. So the total area is not relevant. Definitely an FFS, Imran, definitely. Yes, that can go in your journal, 100%, because it's a very, very common mistake. So what we should be getting is, yeah, 20, I've just checked the answers. Yeah, 27 overall. So it goes 9.75 meters forward. And this number here is 6.5. So half base times height, 9.75. And then it goes back 36.75. So the overall displacement is 27 meters. Okay, to recap, you're stuck on a topic, you go to the revision pack. You go and you have a look and you decide whether or not you're going to do the summary to just give yourself some reassurance that you do know everything and you've got notes on the whole topic. If you need to drill down further, you go into the individual lessons and there's resources here on every revision pack. Then we go and we have a look at the past paper questions and we see if there's any common things that we might want to look at those particular questions to see how they're phrased, particularly look at projectiles, look how often the projectiles includes a word question. Have a flick through by, hang on, let me just see what questions you're asking at a minute. Have a flick through and have a look at the questions. You can also have a look at the number of marks, like on average, how many marks is this worth? Then you go through and you have a go at the questions. So we did this one. So we would traffic like this. This was where we found that all the SUVAT equations come from VT graph. So we've done that one. Which other ones did we do? Oh, that's the one I forgot to screenshot. We did that one. We did this one. So let's call that amber at the moment because we haven't properly fixed it because you're still asking questions about that one. And we did this one and everyone was okay on that one. So that one is green. Okay. There they are. So that means that next time you come to this topic, you already know that you've done those two. That doesn't mean you can't do them again, but you know that you've already done them. And then this one's amber, so we can have a look at that one, go back to that one and try a bit harder at that one. Okay. Let me have a look at what you're asking about this particular question. And then I'll have a tiny break when I'll try and stop myself sounding like I smoked 40 a day. And then I'm going to do some moments with the second years. Okay, which of these questions have you not fixed? Scarlett, could you draw it to 22? No, you can't draw it to 22 because the distance under there, hang on, why am I not sharing? It said that distance was 33. So if you draw it to 22 instead of to 20, then your distance under there isn't 33, and it said it had to be 33. Make sense? So Afia, you're asking about how to use TT for your maths exam on the 4th of May. The funny thing this year is that everybody's exam is on different things. So if you've got an exam on a particular topic, then I'd suggest you do what we did today. So exactly what I talked you through today. If you've got an exam on the whole thing, then definitely TT method. Using the TT method with past papers is what you should be doing. And if any of that is confusing, then give me a shout. If you click in here in content guide, ways to use tailored tutors, so it's right at the top, ways to use tailored tutors on the left, then that will give you in detail instructions on the TT revision method. And obviously at any point, just use the chat. You don't have to wait for a live lesson. You can use the comments at the bottom to ask for specific help on topics you're finding difficult, or on the whole process of using the TT revision method, or on structuring your time or anything like that. Apart from being able to tell that the line goes through 6.5, how would I be able to calculate it? So do you mean, I don't know why let's try and share this again. New share. Can you see at the moment? Can you see my screen or my iPad? Oh, can you? Oh, good. I could see my screen. Right. So question is, how do we know that it is 6.5? Because the gradient is 3/4. Muskan, stay there for a second because I want to answer your question, but I'm just going to do this acceleration bit. So, you know, when we did the connection between SUVAT and VT, and acceleration equals gradient turned out to be V equals U plus AT. Now, if it's easier, just stick to the SUVAT equation, V equals U plus AT. So what would we be asking here? Let me clear this graph a little bit. Oops, that's not clearing, that's making it worse. Okay. So we know it goes up with a gradient of 3/4, so it ends up 4.3. Right. For the first 4 seconds, the vehicle moves with, oh, honestly, I don't know what is wrong with my throat. 0.75. For the next 5 seconds, it moves with a gradient of 1.2. So the gradient of this line is 1.2. Okay. And minus 1.2. We want to find out the time that it takes to go from a speed of 3 to a speed of 0. Do that. We know the acceleration. We want to find the time. We know that it starts off at 3 meters per second. We want to find out when it stops. Choose the equation without S in, which is V equals U plus AT. Stick it all in. They're the same topic. This is the thing. Whenever you do a SUVAT, you're doing VT. And whenever you do VT, you're doing SUVAT, but reduced to only 2 of the equations. Just reduced to V equals U plus AT and S equals a half TU plus V, just those 2. Okay. But it might be useful at some point for you to use your SUVAT. So it's useful not to think of these as 2 totally separate questions. If I gave you a question and said it's up to you whether you can use SUVAT or VT, sometimes it would be easier to use SUVAT, sometimes it would be easier to use VT, but they are literally the same thing. So don't feel that you have to use one or the other because they're the same. And often using SUVAT is so much cleaner and nicer because you have this table, you fill it in, you see the thing that isn't missing, da, da, da. But you're only using, for VT, usually displacement is area is the one that gives us S is a half TU plus V. So you're usually only using those 2. Scarlett, you would, if you put a link, if you go into the course, it says the proof of the SUVAT equations, and you can read them there, but it's simultaneous equations. So you're saying, how would I do, which one are you saying? S is ut plus a half AT squared, S equals U. This one's got no V in it. So what you would do is you would take this one and make it say V equals, which it already does. And then you would stick that into there. And then when you rearrange that, you'll get S equals ut plus a half AT squared. All of mechanics is simultaneous equations at the end of the day. Right, last question before I go on to second years, which is similar to Afia's question. If you have exams on several topics, is doing topic questions and not full papers okay? This is a brilliant question, and we're going to close on this question. If you have a test on a topic, use the TT method on a bunch of questions from that topic, okay? If you have, so like take all these tabs, take questions that add up to an hour or something, create a paper, or just basically it's those questions, and do the TT method. Do them, mark them, think about how you lost the marks, fill in your FFS journal, do any work action hours that you need to do, ask questions, then go back and do those exact same questions again. Scarlett, you're my queen of this. So Scarlett was working on pulley questions where the particle bounces, or pulley questions where this one hits the ground and then this one continues a little bit. Scarlett had a test. I hope you don't mind me telling this story, Scarlett, but I'm very proud of you. And Scarlett was doing loads and loads of questions. Her teacher had sent her a load of questions like this. So connected particles, part C, how much further does it go when it bounces? And Scarlett had worked through these questions. I'd helped when she got stuck, and she was saying, right, can I have some more questions now? Because I've done all these questions. And I said, just try TT method, try coming back and just focusing on these questions. And we did the TT method. And whereas before, when Scarlett was working and she did more questions, her grade stayed the same. She was working really, really hard, but her grade was staying the same. Then when I forced her to do TT method and not look at any more questions, I think it was only like 4, wasn't it, Scarlett, that your teacher had given you? It wasn't loads. It was really like only 4 questions or 5 questions. And then we did TT method just on those. So we'd been through them all. I'd helped. Scarlett had got her head around all of them, waited 24 hours, did those exact same questions again, and then realized that half the information had fallen out and that there were FFSs that hadn't crept in before. So then we used the method, and what was it, Scarlett? You went from an E to an A or a D to an A on that topic, just literally in almost a day, just by using that. YouTube people, Scarlett is honestly saying yes in there. I'm not making it up. Muskan, all of the questions in the exam guide that are organised by topic are pre-2017 questions, but they are exactly the same as the new topic. So you can use them as well. But I bring you back to that main point that doing more questions won't improve your grade. I bet loads of you already know that. I bet loads of you have done that, where you've done loads of work for maths and then you haven't got any better at the topic. And you'll interpret that as the topic being difficult or you being rubbish. And that's neither of those things. It's that no one gets good at maths by just doing a question and then moving on. You have to keep coming back to that same question. You have to reinforce and reinforce and reinforce these links in your brain before moving on, so that they're really strong, so that you can use that as you go forward. Same happened to meds with differentiation. Did TT method for a weekend, went from a B to an A star. Oh, you're so brilliant. It's funny because at the beginning it is hard to trust that the method will work, because it does seem a bit silly and it seems counterintuitive, because in maths we just want a ton of questions, but it does work. Right. Yes, Shania, all the video. Oh, where is there no video solutions in the exam guide? Oh, do you mean all of the extra questions? I put in hundreds of questions where I just put the mark scheme and I haven't done video solutions, but if you're stuck on any of them, just ask me and I'll do you a video solution. But all of the past papers have full video solutions for every single question. Right, I really should swap to moments. Yeah, exactly, Afia. Yeah, do TT method on questions from the revision pack, yes. If they overlap, do you mean, Shania, if they're in two places? If they're in two places, it doesn't matter, because you'll have traffic lighted them. So you'll know what you've done and what you haven't done, because you'll have done your traffic lights. Yeah, video solutions are good, but mark schemes are useless in maths, agreed. But don't forget to TT method. So yeah, use the video solution. Ask me for a video solution if there isn't one. I'll quite happily make you one very quickly, but stick to the TT method as the scaffolding for your revision, and that will make sure that you really get the learning from every question. Okay, moments. Dun, dun, dun. I want to go back, hopefully. Goodness me, we've done loads on this particular one. There it is. Excellent, Ola. Let me know how you get on. And any questions, just give me a shout and I can help out. Okay, second year. So if we are in YouTube and you're a second year and you're doing moments and you've joined in for some moments revision, then first of all, don't panic about what's on the screen. I'm going to go over it. This is something we were doing the other day. So this is a live stream of a class for the TT students doing maths, specifically for second years doing moments. Correct, Shania. Ladders is not AQA because ladders involves friction, and AQA decided not to test friction in the same question as moments. And the only way that you could have a ladder with no friction, well, it would fall on the ground, so it would be no good. So yeah, any question that has got friction in it and it's a moments question, AQA wouldn't ask that, okay? But OCR and Edexcel would. But it's not like it's different specs. It's just literally a decision from the AQA examiners not to combine those two things in the same question. So you won't, if you look at the spec, they are word for word identical. So you wouldn't know that AQA don't do ladders. I only know that because I emailed the guy who writes the exams for AQA and just checked, and he said, no, we're not going to put friction in the same question as moments. So I have that in writing from AQA. Okay, so if you're watching YouTube, I do not have the chat open. I have no idea what you're talking about, sorry. But if you want to join in the chat, go to Tailored Tutors free trial for maths and then click on live classes, and you will have the link into here, which will mean that you can post in the chat that I am actually reading and responding to. So I'm not talking to myself, I'm talking to the chat in the class. Scarlett, you've just learned moments. Your teachers, Scarlett's a first year who has done resolving forces, projectiles. They're just slamming you through all of the mechanics. Like this is the last topic on mechanics. You'll basically have finished mechanics for the whole of the second year. It's been painful. Yeah. Yeah, exactly. Mez is saying, I only learned this last month and I'm in year 13. This is usually the last thing. This is squashed in right at the end because teachers have run out of time and it's the last chapter in the book. And then students, this is the one that I help students with the most at the end, which is a real shame because it is quite tricky and it does need quite a lot of time to get used to. And having it taught to you all really, really quickly or having to teach yourself with this particular topic is not fun for you. Right. Whether or not you want to do it is totally up to you. I'm going to start with where we finished last lesson, and then I'm going to go back to the beginning and take it from there. Okay, so if you were in the last lesson last week, you will recognize this. We didn't particularly finish it, so I want to just use it to talk about the structure of moments. So this is going to be moments in 10 minutes. Let's just make this a bit smaller. Okay. So this is what a moments question looks like. I'm going to go through what every single moment question is, the same 5 steps. And then I'm going to talk to you about which of those steps is the most tricky so that we can focus on those steps. Okay. So first thing that you do in any moments question is that you draw the forces on. Now, some of those forces might need to be resolved into up and down. Not always, but sometimes. If there's a force that's going at a funny angle, then we need to resolve it into how much up and how much down. Okay, so now you've got your diagram. Oh, Shania, that is very nice. Good, good. That is literally what I'm for, is to make maths seem bearable, literally. And I really like it when I can get a topic down to, like, you know, when you go through all the papers and go, no, they are literally all the same. You just do this, then this, then this. They're literally all the same. It's really good. So number 1, we draw on the forces and we resolve up and down. So we can go into that in a bit more detail, but that is step 1. From that point, we are going to look at the diagram and see all the forces pointing up and put them equal to all the forces going down. This is literally just not doing anything, just making an equation. Up equals down. Then we're going to look at our diagram and we're going to say that all the forces going left equal all the forces going right. Again, we're not doing anything with it, haven't even read the question yet. We're just going to create that equation. Up is down, left is right. So we've got those 2 equations sitting there. Maybe put a box around them or something like that. And they just sit there for a while. We're going to come back to them. Let them just sit there. But also be pleased with yourself because you've already picked up quite a few marks just by doing that. Next, we come on to the moments. We decide the point we're going to take the moments about. So for AQA, you won't need to resolve because everything is just horizontal or vertical. Shania, no. Good point. No. Here, look. Here is a dangly beam with a mass on it, and it's attached here. So there's tension in that string, and then it's attached here. So there's tension in that string. And now you need to resolve that string. Or a hinge. In AQA, you get hinges. So here's your hinge, and here's your sign or whatever, and then there's the string, and then you need to resolve the forces of the tension in the string. Good question though. It's just ladders and things like this where you have friction at the point where the thing, so there'd be friction here and there may or may not be friction here. That's what you wouldn't get in AQA. Right, so we come on to the moments, okay? When we do the moments, we do 1 box per moment. That's what these are. So this is really going to help us with the bits that cause the most problems in moments. So in this particular example, I chose the point X to do moments about, only because I wanted to demonstrate how to do the method. I really should have chosen this point to do moments about. That's what I would do in an exam, this point here, because if I do that point, I only have 1, 2, 3 forces to worry about. So I'd only need 1, 2, 3 boxes. Whereas if I choose this point, I've got 1, 2, 3, 4 forces to worry about, which is why I've got 4 boxes. So we choose our moment and we have 1 box per moment. And in that box, all that goes on is a dot and a line. The dot is the point you're taking moments about. The line is the force. And I always use colors for this because it helps me to see what's going on. So here's X, here's R. X is to the right of R and R goes straight up. Notice how it looks completely different from how it does on the diagram. There's X, R is down here pointing up, and I've drawn it like that. And each moment's the same. There's X. What does F look like to X? That's what we're drawing. There's X. What does the blue 76G look like? Relative. It's going down and it's to the right. Here's X. What does S look like? It's going across the top of X. Okay, so each moment has its own box. Right. Moment is built up of 2 things, the magnitude of the force, which we know, and the perpendicular distance of the line of action of the force to the point we're taking moments about, which is the hard bit, okay? Moment equals box. So we're going to be finding out the distances. These are the perpendicular distances. And we're going to really focus on that point because that's the difficult bit. That's the first difficult bit there. And then that is going to give us our moments. And then we get our third equation here for anti-clockwise equals clockwise. Now, the other thing that's good about these individual boxes for each moment is it means that we get really, really good at knowing which ones are anti-clockwise and which ones are clockwise, because that's a common mistake. Not difficult, but a common mistake. You go to the end of the arrow and you follow that arrow round the X. So here's the end of the arrow, go round the X. That is clockwise rotation. Go to the end of the arrow, go round the X, that's anti-clockwise rotation. Go to the end of the arrow, go round the X, that's clockwise. Go to the end of the arrow, go round the X, that's anti-clockwise. So anti-clockwise, clockwise, anti-clockwise, clockwise tells you which side of the equation to put them on, okay? Moment, obviously, I'm sure you know this, a moment is the size of the force, the magnitude of the force, times the perpendicular distance d, which is the distance of the line of action of the force, the perpendicular distance from X to the line of action of the force. So this is the d that we're trying to find, drawn on, okay? Shania, that you should see me doing these. I have to draw that loads. This is what my ones look like this, because this is how long it takes me to be sure that I'm right, that it's going clockwise or anti-clockwise. So yeah, it's a really good way of having it just isolated there so that we can really focus on the thing that we know we might make a little mistake with. Okay. Yeah, wear a watch. So which bits do we need to focus on? We need to focus on this bit here. This is the most difficult bit. And what this method does that I've shown you, this pulling it apart, is it controls everything else. It makes it all really, really contained and simple so that you don't have to think until you're focusing on the bit that we know is difficult, which is the distances. That's difficult thing number 1. Difficult thing number 2 is what happens here in almost all mechanics questions. Almost all mechanics questions end up here. When you go through the mechanics spec, you really realize that essentially mechanics is simultaneous equations. So in this one, we've got 3 equations to do simultaneous equations on. We've got that one, and this one. So we end up with an equation here, and an equation here. And we're trying to do simultaneous equations on all 3 to find out the missing information. Okay, so here's the steps. Draw on the forces, resolve any diagonal forces into the mount up and the mount down, up and down, always up and down. Next step, always the same. Put all the ups equal to all the downs, all the lefts equal to all the rights. Do that before you've even read the question. Only read the question to get enough information to put the forces on, resolve the forces, and then do up is down, left is right. You've already collected a load of marks. Decide which point you're going to do moments about. Totally up to you, but the one with the most forces going through it is the best one so that you don't have to do moments for those forces. Draw a box for each moment and draw in the point and the line of action of the force. Then slow down and work on those distances. Make your third equation anti-clockwise is clockwise, and then stop, take your 3 equations and start doing the messy fun of simultaneous equations. Okay, does anyone want to clarify any of those individual steps before we try them out on a particular problem? Because I'd like you by the end of this session to feel a lot more confident about moments, a lot more confident. Okay, right. So I'm going to go back to the thing that I was talking about at the beginning with the first years about how we revise a particular topic. So up here, I have got all of the VT graph ones that I was setting up for the first years, but we are going to have a look at moments. So we're going to start off going to the revision pack. This is a really good place to start, the revision pack for moments. Where is it? There it is. And then the first thing that we're going to do is decide whether or not to watch this video, make some notes, make sure that you've got the topic in hand. Let's have a look at the questions. So these are all the questions that came up in 2017 and 2018. We're not allowed to give you 2019 or 2020 yet, even though that's stupid, because I know you all have access to them, but we're not allowed. So I can't put up the 19s and the 20s yet. Sorry. This, if it doesn't look like this, Shania, can you take a screenshot and send it to me in a comment? And I'll see if I can work out what's wrong, because it obviously should look like that. So ladder problem, not needed for AQA. How many marks? Oh, lots of, no, look, sometimes only a couple of marks, but if they ask it, it's big marks. Couple of times they've added on a, no, yeah, 2019. I'm not allowed to give you 2019 papers yet. The exam boards are saying they're still hidden. I've done all the solutions to every 2019 paper, like all of AQA, OCR, EdXL, every single paper, every single question, they're all done, but I can't publish them to you because the exam boards are saying that they're still private, which is annoying. So quick look, there's a couple of word questions that seem to come up semi-regularly, so you could have a look at those. You'll see from your traffic lights which ones you've done and not done. You can choose to do an apprentice one or an expert one or a master one, and then you go in, set your timer and just work on questions until that timer goes. When the timer goes, you've succeeded in your action hour. It's not a task based, it's time and focus based. 1 minute a mark exactly. Okay, so let's go in. Would you like the OCR one or the AQA one? Oh, sorry, we won't do that one, it's 1 mark. Would you like the OCR or the EdXL? At the moment, it's equal voting. Oh, what you like? It's equal. It's just going. It's going OCR at Excel, OCR at Excel, OCR at Excel. I'll do the OCR first because it's first, okay? Because it's a 9 marker. So we'll do that one. We hopefully will get time for both. And these are the expert ones. So if you do need to go down a section to apprentice or up to master, then you can do that in your study session. Okay, here we go. So I'm going to copy this and get it onto my iPad. But while I'm doing that, you have a little read through and try to just start the process. 1, draw the forces, resolve any that you need to resolve. Don't worry about distances and all the other stuff. Just get the forces on and resolve the forces. 2, up is down, left is right. There's not going to be any left and right on this one, so you'll only get up is down. And that's where we're going to get to first of all. Okay, so I'm just going to give you a minute or so working on those steps. So Shania, you're doing the forces and then you're going to make an equation. Up is down. That's it. Christine, you're only resolving diagonal forces if there are any. So if there's one going off at an angle, then you're going to resolve it into left and right. So that would be like x cos theta and x sine theta. Yeah, x cos theta, x sine theta. Imran, you're cheating. What I want to show you is the steps, right? So you're almost certainly right, and you've read the question and you're doing the question. But what often happens is that approach only works for the easy questions. And then that's why students find moments difficult, because they don't have an algorithm. It's more of a problem solving approach. So you'll see that we can very quickly answer part I and part II without doing my method. But what I want to do is go through that method to show you that it always works. It always gets you the answers that you want. Okay, so let's see if I agree with you for part I. So we're going to draw it. This is step 1, always draw it, put the forces on. Okay, there it is. Uniform plank, so it's in the middle. The weight is 100, not the mass. The weight is 100. Length I don't care about, I'm doing forces. Plank rests horizontally, equilibrium, 2 supports, C and D. Reaction. And are they either side of the center? The 2 reactions. I'd have to work that out, wouldn't I? So it looks, yeah, no, of course they are. Of course they are. If they weren't either side of the center, then the ladder would fall down, wouldn't it? It wouldn't be in equilibrium. It would be rotating that way, or if they were both that side, it would be rotating that way. So that was silly. Yes, exactly. So they are either side. So we've got magnitude, and then there is the magnitude of the support of the plank at C is 75. And I don't know why I used the same color for that one, because I do like all my forces to be different colors. So now I can call that one R. Nobody's standing on it. There's literally nothing else. That's it. So job number 1, done. Drawn the forces on the diagram. None are diagonal. I don't need to resolve anything. So now I'm not reading the question. I'm going to move on to the next bit. Up is down. Now, from this point, I could just leave it. There's no left is right, because there's no forces left and no forces right. But that is the equation that I need. Then I would move on to the moments. So left is right is we're not doing, because there's no left and right. Forces on, resolve any diagonal ones. Up is down, left is right, moments. So let's just see whether we can answer to here with what we've got so far, or whether we need to do some moments in order to get that far. The next step is going to be the moments. Okay. The magnitude of the reaction, find the magnitude of the reaction of the support on the plank at D. So that's find R, that's saying. Well, I have found R. R is 25. Hooray. Next, find the value of x. Okay, now distances, once this comes into play, the distances, it's the moments that I'm going to need, not up is down and left is right. So let's carry on and do our moments. Where would you like to do moments about? Let's do moments about the end, just to demonstrate. Yeah, okay, so that's interesting because most of you chose A for me to do the moments about, but actually there's no forces through there. So if I do moments about A, I need 3 boxes because there are 3 forces. If I do moments about here, there's only 2 forces. Moments about here, only 2. Moments about here, only 2. So if I do it around here, I do have more work, but that's okay. We can do more work. So now I draw them on. Now, this is going to be a fairly boring one because they're all going to look the same. All of those forces are to the right of A. This one's going down and this one's going up. Yeah, obviously this is fairly straightforward so far. Now we slow it down, although I admit this one is easy, and we find these distances. And we're really careful looking at our boxes rather than looking at the picture, because the boxes really show us that we're trying to find that perpendicular distance from the point to the line of action of the force. That's what we need to find. This is the bit that can go wrong, so we slow ourselves down and really focus at this point. Okay, so the distance to the blue one is the 75, that's x. Okay, the distance from A to the red one is half the length of the plank because it's uniform. The length of the plank is 4 meters, so that is 2. The green one, that is at a distance 0.5 further on than x. So that is x add 0.5. Now I'm going to work out. Oh, I see what you mean, Shania. Yes. Okay, I totally agree with that. I didn't think of that at all. You're right. If we do moments about A, we have an extra moment to do, 3 instead of 2, but X is measured from A, so it's going to be easier. Yeah, I totally agree with you. Okay, clockwise or anti-clockwise? The blue one. Anti. The red one. Clock. The green one. Anti. Okay, now we do the moment. Then we get our equation. So anti and anti, 75x, add 25x add a half. Anti and anti equals clock. Solve for x. You do it, tell me what you get. Solve for x. Agreed, 1.875. And that is the value of x. It's not the distance, so I don't need meters on the end. I don't think you lose a mark for putting meters on the end, but the value of x meters, x itself is 1.875. Okay. Now we're going to kind of start again. Okay. We're going to draw the picture, put the forces on, resolve any that we need to, up is down, left is right, moments. Now, here is a really important thing. When we start again with a new scenario, nothing is true anymore. Unless it was like x is still x, right? X is still the letter x, but here's the important bit and a very common mistake. This is no longer true because things have changed. So that is no longer the reaction at C, and that's a very, very, very common mistake to make. So let's put our forces on. We've still got a uniform plank with weight 100. It's still got length 4. We've still got a reaction at C. Oh, hang on. No, we haven't. It's about to tilt about D. If it's about to tilt about D, here's D. there is no reaction at C. It's no longer touching C. Imagine, it's still flat, but imagine it's lifted up 1/1,000,000th of a millimeter off C. So it's no longer touching C, which means there's no reaction. So if we drew it on, not that I would, but here, there's a tiny gap. So it's not touching. If there is not a surface touching a point, then there's no normal reaction. Whereas here, it is touching and it's about to do that. No reaction at C, just a reaction at D, a different reaction. So be careful, not the same reaction. Okay, what else is going on? We've got a block on the end, but we don't know how much it weighs. It's right on the end. There it is. Draw the picture, put the forces on. Resolve any diagonal forces. None, don't need to do it. Up is down, left is right. So up is down. Left is right, I don't need to do because there are no forces going left and right. Moments. Notice I haven't, this is always the same structure. Moments. Which point shall I take moments about? Totally up to you. D, D, D. Really? Really? Oh, D. Yeah. No, I thought this was D. Because in my head I was going A, B, C, D. And it was the last one. So I thought that was D. And I was like, how are we going to find? No, you're completely right. D is here. So we're going to take moments about here. And the reason that we're going to do that is because we don't know what R is and we don't care what R is. If we were being asked to find R, obviously we wouldn't take moments about here. So how many moments are we going to need? 2. So we have 2 boxes and we do our moments. So D, and then there's the 100 relative to D. D, and then there's the mg relative to D. Okay. This is the thing we're going to slow down to try and find. This is the thing we're going to slow down to try and find. And then clockwise or anti-clockwise. This one, clockwise. I know we know this, but this one, anti-clockwise. So then that's going to allow us to make our equation. We haven't done any simultaneous equations on this one yet, which is making it a super duper easy one, because that's sometimes where it gets really difficult. Okay. Oh no, we will need simultaneous equations, won't we? Because look, yeah, we will. No, we won't, because we're not going to have an R in it. Anyway, let's just carry on and not get overexcited. So let's find these distances. How far is the 100 from D? 0.375. How did you get that, Shania? How do you find that distance there? Two minus x, and then 0.5 minus the answer. Two minus x, but isn't x is over there, right? And 2 is in the middle. So 2 minus x is that distance. And then 0.5 minus that. Oh, I see. I would never have thought of it like that. Yeah. So, no, wait. No, I'm not sure I agree with that. No, I do agree with it. I do. That's, I wouldn't have thought of it, but I do agree with it. If you found this one, which is 0.5 minus x, and that distance is 0.5. So if you then take that off 0.5, this is why D is so difficult, even when it's flat, even when there's no trig involved, it's still difficult. The other option, 4 minus x, gets you this distance. And Yeah, okay. So what would happen if we did 4 minus x and then a half minus that? I'm not sure that works. Has anybody got any other way of finding this d? Because this is the bit to focus on. This is the bit that is difficult, even when it's flat like this. So this is why I'm really slowing down at this point, because this is where we need to be really super careful. Seems simple, but it's not. This is 2. This is D. Yeah, exactly. We need to draw it out and really think it through. And if you're at this point thinking like, oh, I've done this bit, then bear with, because this is the bit that does cause the most problems and the most mistakes. So there's D. And we want to know what this is. And we have no other information. So we can't find that as it is just using that and that. So instead, let's look at C. I'm trying not to draw it equidistant. So there's C. And let's draw it like this. This is 0.5. This is X. This is 2. So I'm coming round to, was it Scarlett or Shania's method? 2 minus X is that bit there. 0.5 minus that bit there is that bit there. She is a genius. But this is the bit that's hard, isn't it? This is the bit where we need to slow ourselves down and give us the time, because this is the difficult bit. And creating separate diagrams is what we need to make that happen. And then our brains can just get through it and look at that information really carefully. Wasn't obvious, I think. Anybody that thought that was obvious, you're cleverer than me, because that was not obvious for me. Okay, 0.375. Is that right? I didn't actually check that, but I think that's right now. So what about the distance D, this distance here? So this is from D to MG. How far is that? So that is this distance here. Now it should be obvious what we can do, because this whole thing is 2. Exactly. So 2 minus 0.375, 1.625, yes. Now that's the hard bit. Getting those D's and then the simultaneous equations, those are the bits where you have to slow down and be careful. The rest of it is okay. So now we're going to make our next equation. So 100 times 0.375 equals 1.625 times mg. And now you can find the weight. And the answer is, if I just take a sneaky little look, 23.1. Find the weight, not the value of m, find the weight. So this is going to be kilograms. Ta-da! Didn't even need simultaneous equations. Does it matter that I did that? No. How long did that take me? Half a second? You're right. If you're thinking, but you didn't use that equation, you're completely right. But so what? If I always follow the same steps, then I know I'm picking up the marks and I know I'm going to get the right answers. Okay. I'd like to do one more with you that involves some. Oh, good point. Wait. The weight is weight, not FFS. Weight is mass times gravity. Is that right now? Good. Did myself a little FFS there. By the way, if you're watching on YouTube and you don't know what FFS is that we're all talking about, it is it is what you think it is, FFS, and it's the times in maths where you go, like, so I know that weight is not mass. I know that. I don't need to do a flashcard telling me that weight is not mass. I just need to remember not to make that mistake. So in TT, we have a little FFS journal. So some people have it as a document. Some people have it as a little book, a tiny book of FFSs, or you could have a slightly bigger one, or you could do them on these cards maybe and start collecting them. But they're just for every time you do something in maths where it makes you think that, okay, every time. And it's difficult to discipline yourself to get into that habit, but it really makes a difference to your accuracy. Instead of saying, oh, no, yeah, sorry, silly me, weight, not mass, I now, because I did that, have to get out my FFS journal, write down, the question said, find the weight, and I found the value of M, which is the mass, not the weight. Weight is, just write yourself a little story even. The more you can make a big deal out of what you did, the opposite of our instinct. Our instinct is to go, oh, yeah, sorry, yeah, duh. That's our instinct. And by doing the opposite of that, by creating this journal and making yourself fill it in every time you do something like that, then it's really going to help you with, you'll see your accuracy start to really quickly improve, which makes a huge difference to grade. You feel like you're telling yourself off. The negative connotation of telling yourself off, I don't like, but I think of it as, this is probably a little bit taking it too far, but I think of it as having a little sneaky little demon in my brain who thinks it's hilarious to distract me so that I make silly mistakes. So it's like my brain doesn't, just as I'm reading the words, find the weight, the little demon goes like, oh, look over there, look, la, 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 la. And then that makes me not quite take on board that it said weight. And then I do maths and then it wins, not me. So I think of it more as a battle between me and this little creature that makes me keep doing stupid things when I'm doing maths. And by tracking what it does, by tracking the sorts of mistakes I make, I gain control and power. That's how I think of it, but that might be a little bit too weird for you. So you can just do it as collecting FFSs, but it does really, really help. It does make a massive difference. Okay, I would like us to do a question which has got some resolving. Okay, so I don't think I'm going to be able to find one that isn't a ladder, but I'll have a look. So let's go back to our questions. Probably going to be a hard one, and it doesn't say ladder, so we might be all right. Let's have a look at this one. Oh, perfect, a hinge. Now this one is going to be really, really hard. This is really hard. Look at this. 1, 2, 3, like 8, 10 marks, loads of stuff that we don't know. It's a hinge problem, etc., etc., etc. This can be AQA. Where's the friction? Oh, the rough vertical wall. Yeah. Did you? Excellent. Yeah, the rough vertical wall means, but I'm pretty sure that no, AQA do need to do this one still, because when you do hinges at A, what you do is you model an X and a Y. So you resolve it straight away into X and Y. Okay, X and Y straight away. Okay, here's what I think I'm going to do. You've got the solution there. You've got me talking through it. So you've got all of the, yeah. I think what I am going to do is I'm going to set you this one as a challenge to work on the method. So this is edXL. If you're watching on YouTube, you can try it. edXL, and it is 2018 A-level paper, paper 3, question 9. So you can get that from the edXL website, or if you're in the course, then obviously you can go straight to this question. And what I'd like to challenge you to do is to go through practicing either this one, which is the hardest it ever gets, or go back to an apprentice one and just go through those steps really carefully. And as soon as you come across a problem, and my prediction will be that the problem is going to come when you do the distances for the moments or the simultaneous equations. Those are the two places where it tends to get difficult. At those points, you can use the videos on this page and you can see how to do it. And meanwhile, I'm going to sit at my computer for the rest of today, and you can jump on the chat and say, I'm finding this moment's one difficult, I'm finding this moment's one difficult, and I'll help you individually, because I think that's going to be more useful for you than watching me go through this one. So I think that's what I would prefer to do here. So I'm going to, in fact, I don't even need to go and get a drink because I've still got some coffee left. So I'm going to leave you to your moments revision. I'm going to sit here, keep an eye on the comments in the chat, put any questions you like in the chat, and I'll be able to help you straight away. And then hopefully we can get on top of moments and start to feel much, much more confident with moments. Do you want to give that a go? I don't mind if you go for easy ones or hard ones. It's totally up to you. Totally your decision. Does that sound like a good plan? Excellent. And also, like, take a little break now. Go walk around for 10 minutes. Change your visual perspective. Breaks, eyes. Think of it however you want. But taking a break, one of the important things for resetting your brain to learn more is to change your field of vision. So if your break consists of doing different things in the same position looking at a screen, you won't feel the benefits when you do your next study session, because your eyes have it. I don't know why. I can't find anything that actually explains in a way that I understand why. But by moving your field of vision, you actually really help your brain to reset and like get itself ready for more learning. No idea why, but it is a fact. So look, even like outside the window over there, or walk upstairs, walk downstairs, look out the window. It makes a huge, huge difference. All right, I will see you in the course. And oh, I see, the neurons associated with the learning stop triggering. But what's that got to do with how far away you're looking? That's what I don't understand. Anyway, I will see you inside the course.